Alright, so this is actually my first time trying to stream on YouTube. So I'm gonna need some verification that things are working the way they should be working. Alright, so someone give me a verification this is actually working. This is my first time working with a stream on YouTube. So anyways, if you guys have questions, just throw them out. I'll do my best to get to them. Today I'm just gonna work on my next project, which is going to be about supernovae. And I am going to work on what's called a Roche lobe. So basically what I'm going to do is, so what a Roche lobe is when a white dwarf is orbiting a large star, so we'll say something like this, the gas out here, far from the center of the large star, isn't super gravitationally bound to it. So if a white dwarf happens to orbit nearby, it's going to pull off all of the gas, and at some point the white dwarf is just going to implode and create a supernova. And that's one of the supernovas that we're going to be working with. I'm going to go ahead and make a little white dwarf looking thing here. Also, if you're wondering, I don't think you're allowed to stream with music. So this is just some, where did you learn animation from? How can I get better animation? So basically, I've always loved science and I wanted to teach science visually. And I had known about Blender way in the past, but Blender was awful to work with. They had this awful UI where you had to right click to select, which was just something I didn't want to worry about, and things were not as intuitive as they are. And so I tried it back in early 2018, I believe, and it just wasn't for me, so I just kind of forgot about it. And then in 2019, let me hang on. About 2019, what happened is Blender released the 2.8 update, and it was fantastic. And so I was just like, all right, I now know how to make like things. I need to figure out how to make this work for me. And so I just started working from there. And you just have to have the motivation. And YouTube is a wonderful, wonderful resource for that. So basically, just ambition and YouTube is how you can figure out how to do most things in this world, in this life. So this is going to be our white dwarf. I want our particles to stick to the white dwarf. So how long does it take you to animate your average video? Depends on how much free time I have. So at the moment, I have a decent amount of free time. This next video is being held up because the topic, I've gone really deep into this next topic and I need to make sure what I'm saying is true. So I found an astrophysicist in the University of Leeds for him to go over my script. But he is very busy because they just started the last 2 weeks. So it's really hard to talk and think about the workflow of how to do this. I've never had to do this before. But he's very busy at the start of the semester. So it's taking a while for him to go over it. So that's why I'm just going to make things I know will be in the script later on. And then we'll work from there. So anyways, what's going to happen here is I am going to put a bunch of particles on our large sun. They are going to be pulled towards my orbiting white dwarf, and they're going to form a really cool looking thing. And then we're going to turn that into a volume so it'll look like gas pooling around our white dwarf. So what I'm going to do is I'm going to make my white dwarf paired up with this empty. And then what we're going to do is we're going to put a driver on our empty to rotate I don't know, at a constant speed. So it's going to look like this. The white dwarf is just going to orbit around it. How do you actually render an actin molecule? I will get to that later, but there's so the best thing about Blender is it's open source. So if you can just think of some way that you want it to work, someone's probably made an add-on that'll work for it. So there is an add-on. Let's see what it's called. I think I have like 3 of them. So I've got BioVision, I believe might be the one I use, but there's add-ons which can read file types that you can use for in basic different fields of science. So one file type in the biomolecular field are PDBs and XYZ files. So if you can get your hands on one of those, you just go File, Import, and then you do PDB. You just go find that PDB file and you'll just import it in, and you can have yourself any kind of molecule, protein that you can think of right there, easy to go in Blender. So it's fantastic. So what I need to do now is I need to add a force field on our white dwarf so it can attract our things. I'll do minus 100, I guess. Can black hole less than mass of star can orbit star? Is your into meant to be unsettling? Intro supposed to be unsettling. I don't know. I made it at the beginning. I wanted each intro to be unique, but then it just got tedious and I just stuck with a random one. So no, it's not supposed to be unsettling, and I apologize if it is. So let's see here. I need to tell these particles not to interact with gravity. And then we just see what this looks like. Oh, I forgot to pair that to my white dwarf. And then I gotta turn off the initial velocity. Alright. Alright, so that's not strong enough, and these guys need to live longer. Minus 500. Alright, so now we're starting to get like, so you can see here, this is going to be a start of what we're looking for. So the particles will be attracted to this general area, and clearly that gravitational pull needs to be way stronger. But also we need to put a separate, because as you can see the particles are going through the star, and I don't want that to happen. I want just the ones from this side to come through. So I'm going to make a sphere right underneath it. I'm going to put a collision on there, and then we got to take off the particle from there. So now the particles over here will just sort of chill, and they'll be pulled towards the star, but they won't actually be able to get over there. And I'll make it a little bit stronger. Minus 1,000. There we go. So it's sort of doing what we want it to do. Ideally, they would get pulled into the star. So maybe we just have this rotate a bit slower, and that'll help. As long as we get the average look is what we're looking for, and then we'll just bump. Once we get it looking sort of like what we want, then we can just bump with the physics and make it look better. There you go. So we're starting to get the Roche globe, the Roche lobe as it's called. So you can sort of imagine. So this is what happens. So what I'm trying to visualize right here is which YouTubers do you subscribe to and get inspired from, if any? So right now I'm working alone. I'm sorry, I'm answering like 3 different questions at the same time. So first one, the biggest one right now that I really enjoy. I mean, Kurzgesagt's pretty good. They put a ton of effort into their stuff. I wish they would go a little bit more in depth on what they do. I do know Professor Jeffries, so that's the astrophysicist I'm working with on this video. He really likes Kurzgesagt, and he says they're pretty darn accurate with the stuff they go into. So Veritasium's great. Physics Girl. What's that guy? Primal. No, not Primer. He's a wonderful YouTuber. Creates little simulation videos. He doesn't use Blender anymore though, which is sad. Do you work alone on your videos? Yeah, unfortunately, this was a passion project where I just wanted to sort things out and just figure out how to do this first. Now it's starting to get pretty good, so I'm going to have to need help at some point in the future. I don't know how that's going to play out. That's certainly something that's going to happen someday at some point. Who knows when, though. So we'll bump this way up to like 10,000. Now the problem here is that in reality, a white dwarf has insane gravity, so these guys should get sucked right into it. So what I'm going to try to do is I'm going to try to cheat the physics, and I'm going to try to put a sphere around this that will stop or significantly slow down the particles as they run into it, and then they can fall onto my white dwarf. So I'm going to make this guy a drag. Please only reboot the logo. Don't change curly the longest. It's my favorite. I love watching science videos and learning about it, but I often find it hard to retain the information. Does anyone have the same problem? No, that's totally normal. I mean, I have to go back and rewatch videos I made to learn what I learned. So, totally normal. How long does a normal video take? So it's probably about 50% research and 50% animation. So animation usually doesn't take this long. Like I've been taking me 8. This probably that I'm doing right now probably should take me like 5 minutes, but it's been very. I didn't realize multitasking doing this is very difficult. But I would say on average, the research part probably takes about. I don't really know hours. I can just tell you weeks. Usually research is about 2 weeks, and then the animation is like a week to 2, depending on the topic. So if it's very particle based, like these videos about the sun. You don't have to do a lot of research, but I can show you, like for example, if I want to do something hopefully interesting. So here's a scene I'm working on for this one. Hang on, I need to swap over to a new window. How do I do that? Sorry, I want to. I guess you can only do one instance of Blender with this thing, so. Oh my god, how do I show you this? Oh, here we go, window capture. Alright, sorry about that. So this is the dude I want you guys to see. Okay, now you should be able to see this one. Yep, okay. So this is a scene, so these kind of scenes, the really tedious, where I just want the scene to look really interesting. Or I'm dealing with like realistic looking stuff. These usually take a little bit longer, but they're also the funnest. So I'm doing a little animation of this guy picking up his little phone here. So you can imagine he'll pick up his phone. And it's always fun to, so a lot of the stuff I don't actually model. There's an add-on called Blender Kit where you can get a lot of the stuff. So the textures, in this scenario, the bench or the couch and these things I just got straight from Blender Kit. And then, yeah, so you may be really impressed by some of this stuff. A lot of it's not me. I do save myself some time, but I did make this little phone here. So my little phone. But yeah, so these things take a little bit longer than just making little particles and fields that just need to move around. So anyways. Alright, no any questions at the moment, so I can just sort of explain what I'm doing. So what I'm doing now is that we have this little animation where our particles from our sun are being pulled towards this. Now, I wanted to add a drag to slow them down because initially they're just flying off away, and I kind of want them to grab onto the white dwarf. What I'm going to do is I'm going to put a sphere around our star to slow them down so they actually fall into the star. So, this wire, change this into surface. And turn the quadratic to 2, linear down is done, and then we'll just paint that to Y. There we go. Alright, so this is an issue. So one thing with drag is sometimes it doesn't work the way you want it to. So this drag seems to have an influence way larger than the sphere. So this is the bit where a bit of like an art with Blender and the simulations. They're not as beautiful and intuitive as you'd like. You can try doing the max distance to like here. Hopefully that works. There we go, that seems to work. So now hopefully my particles will hit, get slowed down, and yeah, that's good enough. All right, good enough. All right, all right, all right. So that's basically what we want to do. So now what I'm going to do is, we hide this. We don't need this anymore. So we want our white dwarf to dampen the hell out of it. So when a particle that hits it, that lose all of its velocity. We don't want that going anywhere. And then even better is there is an add-on for Blender, so it's just endless atom. Random question, do you still make your own music? Yes. Oh, hey Tinka. Yes, I still do make my own music. This is the music that you're hearing right now. It's my own music. I think YouTube doesn't like you playing music that's not yours. And if you, I even looked into it, playing just, God, what's the word? Like, what's that word? When you don't unlicensed, free license, whatever, that kind of music. I'm pretty certain you still have to get permission to play that. So if it's your own music, apparently you can still play that. So yes, this is my music playing right now. So yes, I do make my own music, but a lot of my creative whatever has been focused on this recently. So anyway, so I'm going to use an add-on called Molecular, which makes our particle simulations so much cooler. We enable that here. I'll save this. Royalty free, yes, thank you, yeah boy, Matt. That's the word. Yeah, I'm gonna blame my ISP on that one. I don't know what's up with that. So yeah, my ISP doesn't have the greatest upload, so not ideal. But anyways, what was the last thing I was saying? Oh yeah, so they were asking if this is in a normal binary system. Basically, my understanding is just if the outer layers of a star are going to go to wherever they're most gravitationally attracted to. So in this scenario, you've got a lot of gravity over here in a very small part, and you have over here you have a lot of gravity, but over a large area, so it's not particularly strongly attracted to the large star. So that's why in these systems the white dwarf can suck the gas away from it. What I actually want to do, what I forgot to do, is I want this to come out over 100. Then I want to shrink this guy over time. So after 100 frames, it'll shrink down a little bit to like here. And then I also, there we go. So now what I'm going to do is I'm going to use the Molecular add-on to do some really fancy looking physics. So all right, let's see if this breaks things. So yeah, so this is a lot slower, it does a lot more intensive calculations, but it also does a lot cooler physics. So these particles can actually collide with themselves, and as you'll see, it'll actually stick to my white dwarf here, which is the goal. And if we lose a couple of particles, that's fine, that's how life works. And sometimes it's not perfect, so it looks like this one I might have to tweak the collision settings of the particles to make it look a little bit better. My channel exploded over the last like month and a half. I mean, you go back 2 months and I was just reaching like 25,000. So yeah, it's been pretty insane. I was not expecting this at all. All right, so what happened there is I was baking the physics, so now it runs smooth, but it's a little bit too hectic. It's not quite what I want, but it looks pretty cool. We're getting close. So what I'm going to do is I'm going to have, when the particles run into each other, I want them to absorb all of each other's, what's the word? absorb each other's speed so they don't fly off, and hopefully they'll stick to my white dwarf. Let me make sure my white dwarf is... Alright. Give this another go. So yeah, this is the uninteresting part of of making it, is just tweaking simulation settings until it works the way you want it to. And then once you get the simulation going, then you dress it up and you make it look really sexy. I appreciate that. I try not to let the good words go to my ego. I'm really embarrassed by some of my older work, so hopefully it just keeps improving. Like for example, I think that the biggest thing, oh, that's beautiful, look at that. That's what we're looking for. Oof, got some weird calculations here, shooting particles off, but that's lovely. That's what we're looking for here. Look at that. Yeah, so some of my older videos, one thing I really wish I didn't do is I tried implementing my own music a little bit too heavily in my older videos, so this music is just too intense. And so I've learned over the last like 8 months to just dial it way back and just do really minimalistic music. So, but why? Why should I say but why? So this video topic is about core collapse, and then to a lesser extent, so this is actually near the end of the video, this is going to be about a white dwarf supernova. But basically, as I researched core collapse, I found that it was so much more complicated and so much more interesting than I thought. And I just wanted to go way in depth on it, on like the mechanisms behind it. And so, hence, the mechanisms are so niche and so in depth that I just had no idea if what I was talking about was 100% true. So that's why I reached out to an astrophysicist in Leeds. His name's Robin Jeffries, if you want to look him up. And last Monday, so a week and 2 days ago, we had a meeting and he sort of explained some of the stuff and kind of answered my questions. And then I wrote up the remainder of the script with his suggestions, and then I sent it off to him for him to make sure everything's good to go. And like a lot of professors, he's a busy dude. So he has not checked it out yet. Do you have a PhD? No, I start my PhD officially at the end of this month on November 1st. I've been working a little bit on the beginning now, but I officially start it in November. So my free time may be kind of shot when that starts, and who knows what's going to happen here. But so we got up to... Alright, this is good enough. I don't want to make you guys... I just want to make sure it works. I can fine-tune this stuff later without people watching. So ideally, we would have something that looks like this. They get eaten up. And then at some point, I can just have it explode into a black... yeah, there we go. Good enough. Perfect. Alright, so let's dress this up. Let's make this sexy. You guys can see how to dress up a scene. Why does mass spiral like that instead of just falling directly to the other body? Sorry about the dumb questions. No, it's not a dumb question. It's just, you have to think of it like it's falling to where it was at that given moment. So it's instantaneous velocity. So at this given moment, it's being gravitationally attracted to this point. But then if we move, now it's over here. So it's got to, update and start getting pulled this way. And then it's got to get pulled this way, and then it's got to get pulled this way, and it's got to get pulled this way. So basically you have it always being attracted to where it was, instantaneous point in time in the past. So it's not going to fall directly towards it. So totally valid question, totally normal, because you would think, why wouldn't it just fall straight to it? But it's not. When it started falling out here, it used to be over here. So it makes sense for it to want to go here, but now it can't. It's going over here. So this looks good. I'm happy with it. I'm going to dress up this thing. So first thing is first is we need to add in some HDR magic. So I go to my space HDRs and we'll throw in a star map. To make a black hole lensing, if you make a black hole, you can use a sphere with a facing... Yeah, when I made the black hole, I had to follow a tutorial on YouTube about this guy who did some crazy... Oh, is that what DVR is? I'm sorry, Devin Shu. I thought DVR was just some unnecessary thing to burden me with computing. I do another one of these in the future, I'll be sure to enable DVR so you can do that. I just kind of wanted this to be a... Is anyone actually doing Blender? Like, can I answer someone's question? Yeah, so sorry, I disabled DVR because I thought it would just be more processing or something, and didn't seem like it would be that necessary. First off, we should label these things. So this is a collision sphere. Don't need this. Can hide that. We will make our red dwarf. And then we will make our white dwarf. Yeah, so this, I mean, Blender, the thing about Blender is like I'm doing simulations right now, but Blender is anything you can imagine. It's insane. Like there's a whole nother section for sculpting. There's a whole nother section for animation. There's a whole nother section for hard body sculpting. It's just, it's so cool. And that's why I love it. It's so versatile. So actually with my red dwarf, I am going to steal a star I made for my last video because it was a nice star. So what was the name of that one? So we'll just do this guy and make it look more red dwarfy. So that looks like a star here, eh? Can I script Blender? I only like things that produce a differential in VCS like Git. Blender accepts Python, so I've got really basic Python scripts that I've written for Blender. The API isn't super intuitive. It's decent, but you got to do a little bit of hamming to make any script work in there. But it works. It's cool. This guy is my white dwarf. We'll give it a white dwarf. And then a white dwarf is usually very bright, so we just give it an emission and crank that up to like 10. And we add some bloom, so it's little shiny looking things now. So now what's going to happen is we have our red dwarf. It's going to shrink. I can change the colors, make it a little bit hotter, and then that'll pull the particles into my white dwarf, which will inevitably shrink it a little bit. And then at some point I'll just have it explode. And I don't need to do that on stream. That's a lot of hamming and just guesswork, but you can kind of see how the scene's going to work. But what we can do, which is really exciting, and I will show you, is we can use our particle system to drive a volume system. So we can make like a, what's the word? We can make a, just looks more cool. It looks sexier. So let's go with that. So we change it from flow, and then we change it to an inflow, and then we just choose the particle system. So now what's going to happen is we're going to create a volume, and it's going to be based off of the particle system. And I'll make this smoke red, I guess. And then what we have to do is make a big old box to put everything inside. So this box is going to be the actual fluid itself. Make it an adaptive domain. And I will do this rendering in solid mode, or this calculation in solid mode. And I'll bump the resolution up just to give you guys, I won't do all this stuff on stream because this is really tedious, just waiting for things to calculate, but I can show you it's so cool what you can do with Blender. That's why I always tout it to anyone I meet. I say, just learn Blender. You want to see how you make that thing explode. I'll probably use a particle system for that as well and just make it look like an explosion. But first things first, where is my bake key? Oh, I have to go here. Duh. No. Where's my bake button? This is embarrassing. Where is the bake button? Oh, here's the bake button. Oh, that's why I had it on the replay. This is what I wanted. Okay. So it's going to bake out the volume now. Yeah, so I was thinking about doing the metaballs, but the thing is, so I did the metaballs with the supernova in my last video, but when they get really big, the calculations for the vertices for the metaballs is insane, and those final frames take ages to go through. It's crazy. So now if you look at this, something didn't quite go the way we wanted. Ah, this is the dude I wanted. Okay. Alright, is that working? Oh no, things aren't working the way you expect them to. Oh, I didn't select the particle system. My bad. Do you do any Blender scripting in Python? If so, can you recommend some good tutorials for some? God, who was that dude's name? So let's make sure this is doing. Yeah, there we go. See, now we have a volume. That's not really doing what I want it to do, but you can see now we have a volume that's doing what we want it to do. So it's going to look a lot more ethereal and not so particle-y. So let me just do a quick baking of that, and then I can show you what that looks like with lights, and it looks really cool. Thanks for the tip, broccoli, but yeah, we gotta go. We're working through it. But yeah, so another thing to know about Blender is there's two types of renderers. There's the physically based renderer called Cycles, which is going to get a cool update in the next update. So, you know, if you want to learn Blender and make things look really good. But recently, Eevee, which is what I'm using, they had this cool update for their volumetric system. So when this is done baking here, I can show you how good the volumetrics can look in Eevee. And it'll just look really nice. All right, so now we'll have this thing. Yeah, it's interesting. Ah, crap, I should have moved this over. Whatever, I'm not going to make you guys sit through this. I'll just put a volume on here and then... So we're going to add a principal volume, plug that bad boy in, give it a red tinge, I guess, because that's fun. And then... what is it, density? Does density exist on this guy? I'm going to trust that that works. It might not work. Oh, it does work. Sweet. So actually, I don't want this to be quite like that. I kind of want to show you what it looks like with a sun shining down on it. There you go. So you get like this nice little smoky looking look to it, and then we can of course turn the density down. And turn the density down so you can see a little bit more. There you go, see? Isn't that cool? I don't know, I always geek out every time I can see like the little smoky thing. But yeah, I'll fix that up later and make that better. So, so yeah, then it'll just be a mix of particles and smoke, and it'll look really good. And obviously I'm not going to do that on stream and waste your guys' time, but I'm going to tweak these settings in the final render and it'll look really cool. So that was one thing I want to do today. And then the next thing I want to do is I need to make my iron core. So, actually I can do this animation. You guys can see some animation. So let's swap over to that. Do you do any Blender scripting? Will you be doing more live streams like this? Yeah, sure. I mean, it's a good way to force me to actually do progress. I mean, right now that my biggest thing I'm waiting for is like for my script to get fact checked by the professor. So I've been kind of slacking on the blendering because I don't have a script, and I like to have the audio or the voice track here, which so I can help me time the animations and everything. But I can still get basic animations out and then just tweak them a little bit later with whatever. I forgot words. How did you learn Blender? You have any way to donate? Yeah, your time. You can just watch it, man. Like I said, this is fun for me. I as long as you get inspired by Blender, you can donate your time to learn Blender and make yourself a more creative person, and you know, contribute more things for people to do. But as far as how to learn Blender, just YouTube videos and just start playing around with it. The hardest thing to do is you need to have an idea. So you're like, I need to do, once you know what you want to do, then you can start figuring out how to do it, because it's overwhelming. There's so many things to do that if you're just given Blender and you're like, do something, you're going to be confused and be like, what is going on? How much of a GPU is needed for Blender? So it depends on what you're trying to do with Blender. So what I'm doing, I used to have just a standard, it wasn't standard, but a pretty decent gaming laptop, and that would render Eevee out pretty good. There's some things that are really difficult to render, like volumetrics and like motion blur, post-processing stuff. I would recommend sticking with Eevee though if you have a bad GPU, and just get used to Blender, and then maybe someday you can upgrade. But I'll show you what I'm talking about. So this is Eevee, and then Cycles is where things look really, really good, but it's really slow because it's doing physically accurate rendering. So it's bouncing, you know, individual photons after each surface, and so it looks really, really good, but it's really slow. So anytime you, this is CPU. Oops, let me change this to GPU. So I know a lot of people here are saying that it was the GPU. No, it's just, I don't think my internet ISP or whatever is designed to have constant uploading. So maybe there's like a weird cap or something. I don't know what that's about. Very strange. So yeah, I haven't. I usually use optics on. I haven't done any cycles on this version of Blender. I save cycles for the next version of Blender, which has the updated cycles. So I haven't loaded the GPU kernels into this, so I have actually frozen my Blender while it's trying to load these kernels. So I might have to kill this guy and start over. There we go. So we will go back to this guy. So we are back here. Let me try that again. But anyway, so that's the thing. If you want to make it look really, really, really good, you're going to need a quality GPU. And I do have a nice GPU, but it's just, even with a nice GPU, you're looking at 40 seconds per frame if you don't want to do like high quality, high sample count renders. But if you just want to do a single image, then yeah, any GPU will be fine as long as you have time and you trust that what you've done is going to work. So let me get a new window in here. All right, so I will now show you guys how you can animate things. So what I'm going to do with this thing is what I want in this scene is for the dude to get a text message on his phone. If you look at it, it's just a generic notification I found, so it just looks like there's a notification. I'm not going to go that far into it, but basically his phone's going to light up, he's going to pick it up. And this little scene is to demonstrate that each time you pick up an object, you are counteracting the entirety of gravity, Earth's gravity. Just a little interesting scene there. So first things first, let's have the phone turn on. So screen. Here we go, this guy. So we'll just have it go. Oh, what the fuck? I have an old voice chat from an old voice thing from a previous video on here. Have you heard of Captain Disillusion? Yeah, I've been God, what was there was a video Captain Disillusion did ages ago, which was my first Captain Disillusion video. It was the one where they were playing basketball, and the basketball disappeared behind the kid, and I was just obsessed with the quality. Even back then, like the quality was insane, and it's got nothing but even more insane since then. So yeah, I love Captain Disillusion. I probably should have mentioned that. I don't know if that person's still here, but Captain Disillusion is someone who I would highly recommend if you're interested in educational channels. So this guy's gonna look down at the phone and be like, oh, there's a message going on here. Demonstrate. So, believe it or not, your work is helping space discovery, not just educating people who are interested in physics. You're doing that. I think the one person you wrote about tidally locked, I'm not an expert on this, but I'm pretty certain tidally locked, you need to have a slightly like fluid body or whatever, because I believe part of it is that it squishes and stretches the material of the orbiting thing so that it's just slightly stretched out, so it is slightly more gravitational. And I can't explain it. Let me make just here. So I believe, I'm not an expert, don't take this. This is just what I believe is going on. I believe over time, so let's just say this guy was orbiting around the sun here. I believe because of the way it is, that it'll get stretched this way just a little bit. So that means it'll want to preferably have this side closer because, you know, it doesn't make sense to be like this because you can lower the energy by having it like this. So I think you have to have some sort of squishiness to whatever it is. And I believe in the early days when the moon smashed into the Earth, it was still pretty hot. And I have to imagine some squishiness happened, and so the moon is just slightly kind of like this. Like, we're talking tiny amounts, but I believe that's one of the principles you need to be tidally locked. I'm not 100% certain on that though. Quantum macrosums like superfluids. I'll be honest, I'm not a quantum physicist, so I have no idea what you're talking about. If I can get papers that explain it to me in a way that I believe I understand it, I will totally look into it. But I'm just a climate scientist. So anyways, earlier someone asked what my PhD is going to be in. And God, it's so hard to it's so hard to focus on, think of like what needs to happen next and talk. All right, so sitting here, phone goes. So my PhD, I'm a climate scientist, and I work with not internet technology, IT, information technology, and sorry, this is hard to focus and plan what I'm going to do and talk. So what I'm going to do is I'm working with machine learning, and I'm using a paper that a guy at my institute wrote 3 years ago, and then he also did like a secondary paper on that this year of a method to detect multivariate climate anomalies in the world. And so what I'm going to do is I'm going to use that paper to identify climate anomalies, and then I'm going to use Sentinel data from variables around the world, and I'm going to try to find some way to predict using machine learning the small-scale impact of such climate anomalies. Because right now, our climate models that we have are very, very coarse. So we're talking on like 30-kilometer grids, you know, one by one degree grids. Like if you tell you it's going to be a drought and you're a farmer, like you don't really know what that's going to mean for your farm. So the idea of this PhD was very tangible evidence on a very small scale what a specific extreme event will mean for, you know, average Joe living wherever. So that's what my PhD will be about. Okay, so let me just see. I don't even know what I'm doing. All right, so he gets the buzz and he goes, oh, look, yeah, there we go. Oh, look, a message on my phone. Oops. There you go. It looks like he's looking at the phone now. So he goes, oh, there you go. Oh, I forgot to delete this thing again. No, it got deleted. You should hide something in the background. I used to do that a lot more in my earlier videos. So I had the one where the dude was reading a book and the book title was like something inappropriate, like My Evening on Fireman John's Rod or something. I don't remember what it was. I hide little things in the background every now and then. Kind of just depends on how much effort I want to put into that Easter egg, because it's not the easiest thing to put a shirt on this dude and then put your own custom image on the shirt. Can you look at the weird geography of the island PEI in Canada? Let's see. PEI, Canada. Prince Edward Island. What about it? Kind of looks like there used to be a volcano in that general area, maybe? I don't know. It's got a little bit of a bulge to it. Alright, so this guy gets shot, and then he will stretch that out a little bit. And he'll come pick up his phone. How do people pick up their phone? Where's my phone? How do you pick up the phone? You go like that. Okay. What's your build? I have... it's really beefy, so I guess it's embarrassing that I don't know what it is. It's like a Ryzen 9 something and then a 2080. I think it's just a standard 2080. This was a graduation thing I wanted to do after I finished grad school. I wanted a nice computer to help with rendering and stuff. An Optum mechanical engineer building spectrometers to help detect Earth surface mineral dust source investigation. What's an Earth surface mineral dust source? What exactly does that mean? So I just want to clarify, people who might think I put a ton of effort into videos. It normally doesn't take me this long to animate. This is ridiculous. So it's not like I'm putting 40 hours per scene or something. What's this video about? This video, as mentioned before, but no problem, is about the core collapse of very massive stars producing supernovas. So this is actually going to be the very, very first scene of the video, is this dude picking up his phone. Yeah, I'm not going for an anatomical accuracy here. I'm just doing a dude doing his thing. So let's say you pick up a phone, I go like this, I curl in my fingers, and then the phone rotates up. Okay. And I apologize if I missed some of you guys' messages or whatever. I'm not a proper streamer, so I don't have the two screens set up so I can see everything and whatever. Alright, this is good enough. Yeah, good enough. Okay, and then so I go like this, and then I put my thumb here. Like that. Oh my god, that's ugly. Oh my god. Yeah, something like this, whatever. As much as I love my music, I'm gonna try to skip. I'd have lyrics in that one. Alright, this looks awful. I'm not gonna spend that much time on it. This is an opening shot. It's gonna last like 8 seconds probably. So So now the phone is going to magically start here and going to come up to here. Looks like he's holding the phone, right? All right. Now what we're going to do is we're going to tell it to follow the hand at this point. Okay, I've watched a few tutorials on Blender. I didn't know you could do all this with it. Wow. Yeah, no, Blender, you can do anything, man. That's the thing. People don't realize. They're like, this is a free software, but the sky is the limit. It's insane. So what we're going to do now is that now that the phone is physically in his hand, I'm going to attach the phone to his hand so it doesn't go anywhere. So we're going to go to a constraint. We're going to create a child of constraint. And we're going to tell it, hey, get attached to the hand. This is the left hand. So we do hand, IK, L. And then we do set inverse. And now we have it. 100% here and 0% here. So now, when I move the hand around here, you will see it will follow the hand around. Isn't that nifty? Now I can do whatever I want and it'll stay in his hand. Are there collision detection settings? Depends on what you mean. I'm gonna say no, because that seems like something that's not in the... why does that happen? Oh, and this needs to get moved over. Oh, that's fine. Yeah, it's good enough. So now just raising this up to the head. Get rid of this. Can you make the person 100 times bigger? You can do anything in Blender. Like, honestly, just let me finish this animation. Give me a request. While I'm doing this, write in something. I will give it a shot. You can do anything in Blender though. Okay, how do normal people hold a phone? They bring their thumb down a little bit. That's what they do. Oh, this is not ideal. Whatever, I'm not gonna put a lot of effort into this. That looks good enough. And then the head's got to look at it. And then maybe do this a little bit. So, phone. Oh, and he picks up the phone. There you go. There was that, like 10 minutes to get 2 seconds worth of animation. And then, of course, you can monkey with it to add little bits of... I believe I already added some noise here. So we do graph editor. No, I didn't add any noise here. Well, I'll add some noise. So we basically, to make them a little bit more spicy and a little bit less static, what you do is you add like a random modifier so their head jiggles like this, so it looks like they're a little bit more alive. So I have, there's something somewhere. Is it this guy? Yeah, I don't know. Someone somewhere has a noise, because I'm not doing this. Am I? Yeah, no, I'm not doing that. Can you model universe in Blender? Animate the Lord of Rings trilogy. I think the model with the phone looks good. Thank you. Do you happen to have Discord server? Yeah, that's something I'm thinking about doing. I've been kind of conflicted of how to move forward once I start my PhD and I have less time, but I think if people want to offer to help with like research or whatever, I might want to make like a Discord and be like, hey, I don't have time to look into this whatever for the next topic. Does someone want to find a source and figure out how this mechanism works or whatever? So yeah, hang on. I was talking and forgot what I was going to do. So I'm just going to add a little bit of noise to the rotation here. So we click X rotation, add some noise, so you can see he's very lifelike with his movements now. I'm joking, of course. Oops. So there, now he's got a little bit of head wobble. And then we'll just add a little bit of shimmy to the shoulders like this. And then I'll be done with this scene. It's good enough for me. X, Y, Z. That's what we want. It's a little bit too much. And I'll dress this up later when I have the actual audio file to work with. What is your PhD in? If you could make a living off of YouTube, would you? I mean, it's certainly really attractive. Like, as much as I enjoy what I'm doing right now with my research, this is certainly something I enjoy doing more. But my research is a consistent income. I don't have to worry about views, and I don't have to worry about disappointing. I don't have to feel like, oh, I need to do this, and oh, I need to do whatever. So that's one of the most attractive things about a PhD, is not feeling like a slave to YouTube and needing to play YouTube's rules to get clicks and whatever. But at the same time, like, I would rather do this than some of the stuff I'm doing. So it is a dilemma. And yeah, so Joseph, I did mention earlier what my PhD was in, but the gist of it is going to be climate. We'll call it climate projection for we'll call it what was the official word for it? Downscaled climate projection of. I don't know. I'm going to use machine learning, and I'm going to we're going to use a multivariate system that was written in a paper at my institute to detect extreme climatic events. And then I'm going to use a method using satellite data to show what it's going to look like on a small scale, like high resolution, like in your backyard, what's going to happen. And theoretically it should work, but that's the thing with machine learning. Even though it should work, it might not work. But I think it'll do pretty good. I've seen some cool papers on precipitation in Brazil that were pretty accurate, so I have optimism for how this will all play out. So what I was going to do is add some noise here and be done with this. There you go. Kind of looks like a person. All right, good enough for this scene. All right, let's make my iron. Is it a dilemma, or is it just a perfect balance? At the moment, it's a perfect balance. It works good for me. The reason I'm lagging in my next video is because I went really in depth in the research, and so I'm waiting for. Is there a way to update the window? Can I just change which one it is, or do you have to make a new one? I just make a new one. Okay. All right. So just God, what was I talking about? So along the lines of parameterization coupled with neural networking. So it's actually mainly I mean, I can. If you want to look up the paper, it's by Milan Flach. I have to look at the exact title, but it's basically. God, I can't think of the title. I just read it earlier today, but basically, it's using a word for large math thing. What's that called? I'll just use function, but it's using a multivariate function to detect climate anomalies, which I don't understand yet. So that's part of my PhD, is learning how exactly they did that. And then when I find the anomalies, we create what's called a PCA, it's a principal component analysis. So I find similar points around the Earth, and I'm going to pull the satellite data for those similar locations, and then from there I'll do we'll do machine learning. And yeah, sorry, I'm a little flustered because I'm trying to think of multiple different things. But yeah, the PhD is still in the very fresh. So although I have a pretty good idea of the roadmap, I can't tell you a lot about how it's going to play out. Okay, so we are making an iron core is the goal here. For where am I from? So I am from, can you add the link in the description? Yeah, hang on, let me do that for you now. It's in my email, hang on. Okay, I don't want to, I didn't think it would take this long to find. Okay, perfect. Yeah, okay, I found it. I'll be honest, why is it so unintuitive to find where my, oh, here we go. Okay, perfect. Now I'll be honest, why is it so unintuitive? Yeah, that was, all right, there we go. Here's the link. All right, so what we're gonna do now is we're making an iron core. So we're making a ton of iron in a core, and then I wanna like shrink them all down to show the core collapsing. How do you feel making me binge watch your videos? I'm surprised if you can retain the knowledge from binge watching my videos. Even I think the old videos are just too much. And so I appreciate it, but you, careful there. What am I trying to do now? Oh, that's what I gotta do. I gotta separate this. Are you showing your innovation in Expo 2020? I don't know what Expo 2020 is. Also, it's 2021, so I think it's a little too late for that, unless it's like the Olympics and it got delayed. Can you make an atom of irony? I don't know if that's a typo, but this is my atom nucleus, or my iron nucleus. And basically what I'm going to do is I'm going to create, this thing is just going to be the core, I guess. And I'm going to put one of these on each one of these little dots. So what I'm going to do is you click here, and you click parent object. And then there you go. I'm going to move this to, where's the original one? There we go. And then what I want to do is shrink those together. What this video you're working on, how is going to be about. All right, maybe next time I'll put a DVR so I don't have to answer a lot of the questions again. But this question is about core collapse of large stars. So basically what I'm going to do here is we're going to have, I think I'm going to have to whip out animation nodes for this one because I need way more than this. So you guys are going to see some pretty aggressive visual clutter. You'll be like, what am I looking at? But anyway, so what's going to happen here is basically what happens is as the core of a massive star collapses, so you imagine all these nuclei of iron, as they start to collapse, it's going to get insanely crazy hot and it's going to produce gamma rays. Now iron, as we can see in this previous scene right here, iron is the most stable nuclear arrangement. So if you give iron more energy, it's not going to, whereas before if you gave any of these atoms more energy, they would get more and more stable, and that's why fusion happens. But when you give iron more energy, it can only get less stable. So what happens is that when our core starts to shrink and get really, really crazy hot, the gamma rays actually break open the nuclei of iron, splitting them apart, making them less stable, and thus our core loses the ability to stay, its shape it is, which causes it to collapse further, which produces more gamma rays, which causes it to collapse further. And while this is happening, the pressure is causing electrons to fuse inside of protons, which is causing the protons to turn into neutrons, which is causing electron degeneracy to drop, which is causing the core to collapse even further. And this process is just crazy fast. And so what I want to show here is that the iron is going to collapse into this or whatever. Yeah, so the chart I have helium twice because it starts off, the very first reaction is I forgot to put it here. You can see that this is tritium. So tritium is helium with 2 neutrons, and then you have helium up here. I haven't added the numbers here yet. So you can see here there's a 4 and there's a 2. So yeah, good catch. But yeah, so the first nuclear reaction is the formation of tritium, and then that will shoot up to normal helium after a couple hundred years when 2 of them bump into each other. If charge is an intrinsic property of matter, why do electrons and protons have the same value of charge, although they have different masses? I don't know. Unfortunately, I can't tell you with that one. It has to do with just the way I think the quarks because an electron is a fundamental particle, and so imagine I don't know why I made a plane. So if you imagine here you have an electron. I'll make that blue for you, and then here we'll make our proton. So our electron is actually a fundamental particle, like this is, quarks or whatever. This is as small as you can get. But a proton is actually 3 fundamental particles. So I have no idea. I'm sure someone has a better idea, but the actual charges of the quarks themselves are fractions. And so I have to imagine that the interaction of the quarks inside the proton only works when the proton produces a charge of 1. So I don't know. I'll be honest, I don't know. But my guess would have to be that the quark interactions inside a proton wouldn't work or wouldn't be stable or whatever unless the charge itself was 1. So that's my guess, but I do not know. No, I'm not familiar with Thorne-Zwickau objects. All right, so what am I going to do here? So I don't need this guy anymore. Oh no, where did it go? Oh no, where did it go? Okay. I don't want to delete. Okay, perfect. I didn't want to delete that. So what I'm going to do is I'm going to create an instancer where I'm just going to put a ton of these guys. So we'll do, let's 525, 125 of these guys. We do object, instancer, transforms output. Oh no, I have to make them real? I don't want to do that. So unfortunately 9 nano, I didn't think that people would care enough to rewatch a stream of mine, so this is not archived. I guess in the future I can certainly do that. But as of now, no, it is not. So I apologize for that. So instead what I'm going to do is I'm just going to do this a different way. I'm going to make a mesh out of all these points instead. So what you can do, and this is a separate add-on for Blender called animation nodes, and you can do, whenever you have like a lot of crazy stuff happening, I'm usually using animation nodes. So what I'm going to do is I'm going to generate a ton of vectors here. As you can see, here's a list of vectors. And I'm going to say each one of these vectors, I want you to be a single vertex in a mesh. And then I'm just going to do what I did here, but on this large mesh. We do mesh, combine mesh, give it the vertices, mesh output. So you see now we have a box of 125 dots. And the hell with it, let's bump it up to 1,000. And there we go. So now I am going to turn off my node tree so it doesn't keep going. And then we're gonna see if this crashes. No, it shouldn't crash, we're good. There we go. Oof. Yeah, it's struggling. Ooh, it doesn't like that. Okay. Yeah, so we have 1,000 little iron things here. So maybe I'll run a little bit faster and yeah. So it's struggling with this. It doesn't particularly enjoy it. So we're gonna go ahead and knock this down to a little bit less. So now what I can do is I can have them scrunched together like this. It's not technically accurate because they're not like smushed together in the correct format, but it's a lot easier to just animate that than to just do what I was doing before. So now I can just have them shrink together. I'll be honest, I don't quite know what I want to do for this scene yet, so I'm not going to play with this a lot more. The girlfriend thing is on the step. It's in process. Let's say I'm optimistic. I'm pretty new in the city, so I'm also an introvert, so it's not easy to meet people in a foreign country when you're also an introvert. It's not the easiest thing, but I am pretty darn cute, so I'm not super worried on that front. But give it some time. 57,000 objects. Yeah, it is 57,000 objects because each iron head. Technically, there's 55. It's missing an extra iron because it's not totally accurate. Yeah, I'll be honest. I don't really quite know what I want to do with this right now, so I'm not going to do that. Let's go look at the script and see what else I can make. Oh, here we go. We just make some neutrons and protons. That's simple. So we just make our little neutron proton quark thing going on here. So we have our neutron, proton, already had a neutron, I just slipped that over. Working on assets in Blender, but why? Got a favorite star type? Not really. I'm not an astrophysicist. I just like all kinds of science. I don't know enough about stars. I can tell you about climate, but all right. So think I am going to make this I'm going to make this a disappearing guy, and inside of it I want to put make this a collision, and then inside of that will be another guy that we don't want to look at, and he will have my quarks bouncing around. So we will put our collision, add particles. We'll just put 3 particles in there, and we'll have them bounce around. And I'll show you another really interesting thing you can do with animation nodes. We don't want it to be affected by gravity. What foreign country are you in now? I'm in Germany. So I'm originally from Minnesota in the US, but I haven't lived there in ages. I did my bachelor's in Puerto Rico, so I speak Spanish. But yeah, I'm doing my bachelor's I'm doing my PhD in Germany. So what we're gonna do is we're gonna have these particles bounce around, and I want them to be like avoid each other, but also attracted to each other. So I'm gonna have them be their own field weights, and I'm gonna have them be, should they just be magnetic? Will that work? Let's see what happens if I make them magnetic. Okay, that's not super interesting. We can hide the... There we go. So we just have to figure out what kind of thing we want to do to make them work. I can just throw in actually what I'll just do is I'll just throw in a magnetic, but also throw in a big, strong turbulence force field here to monkey with things. So just turn this up to like 10. And then add in a little bit of noise. There you go. These are going to be our quarks. And so what you can do with animation nodes is I want to show that they're connected to each other. So what we're going to do is we're going to get the particle data from this guy. It's my particle system. Yeah, particles. Kannst du auch Deutsch? No. German is I try not to curse, but German is a bullshit language. So in English, English we have the, okay? In Spanish we have la, it's supposed to be an A, la, el, and then los and las, okay? It's a little bit more complicated than the, but whatever. Now German, you've got der, just der, die, das, dem, like decim, and then all 6 of these guys get swapped around interchangeably. You don't know when to use them. So no, German is so different. I know a little bit, like I can pick up like what people are saying every now and then, but I get so discouraged when I try to learn it because there's so many rules that are so different from English. So my dream is to speak German. So ever since I was a little kid, I had dreams of yelling at people in German because it's such an aggressive language. But no, unfortunately, German's not my language at the moment. But I think that would certainly help me meet people if I was a little bit better with German. So, but there's just so many things to focus on. It's hard to focus on research, language, and then videos and stuff. But you know, I'm sure at some point I'll force myself into it. So what am I trying to do? I am trying to make a spline out of these points. So we bring in these points, create a spline output, and then we make it cyclic, and then we say yeah, and then we turn the bevel depth up a little bit, and we turn auto execution on, and we say hey. Why is there more than 3? Why did this guy get made? There we go. So now we have our particles are connected. Ain't that nifty? Look at that. Look at that. German is a quantum. I have screencast actually, but it's just funky. I don't know if it's my problem, so I can show you. As soon as I try to enable screencast, it goes, Python did not like what you just did there. So, yeah, I'll have to figure out if that's an issue with the current version of screencast or what. But yeah, it doesn't like it. So now what we gotta do is make our little RGB quarks up here. So R G B. And then we're going to make that these three particles here. So what we do is make that into a new collection, so we'll call those quarks. Then we click on our particle system and we say, hey, I want you to be quarks. And then we need them to be a little bit bigger. There we go. So now we have a little quark action going on inside of our neutron. Thank you for the content, bro. Tu mochila es la biblioteca, señor. So, I don't really have an accent when I speak Spanish, but I find that I have difficulties finding the words when I speak it. So, si para los latinos en la pública yo puedo hablar así para ti por unos minutos. So now that the one thing I don't know how to do, I have to figure out, is I need to throw an up, down, and you can't really do that with this. So I'm going to try something nifty here. I've never done this before. I am going to... So a neutron is two downs and an up, so we'll try this really quick. Put an up and a down. It's a big D? I'll do a little d. Little u. And we'll make this a collection. And we'll call it label quark labels. I don't know if this is going to work, but if this is going to work, this is why I love Blender. If you have this idea of something that might work, it might work. So what I'm going to do is I'm going to use the locations for, so here we go, click Objects, Collection, now we get Collection Info. And basically I'm going to take the locations of these and then tell my letters to go there, and I think I can get this to work. And so this is when I love Blender and programming, when you have an idea and then it works. And I'm pretty certain this is gonna work. Hang on, I have a roommate is probably gonna start practicing trumpet. So if you hear trumpet, it's because I have a musical roommate. Okay, so object output. And let's see if this works. Awesome. See, this is why I love programming. You just have this idea of how to get the letters to work on your thing, and bada bing, bada boom, you got them working. So now what I can do is just so if I have a camera, do I have a camera in the scene? No, I don't have a camera in the scene. So what I'll do is I'll just have it so each one of them faces the camera, so that doesn't matter where they are. So back to the camera. Oh, that's backwards. Back. Yeah, that's good, dude. No worries. Are you planning on leading a coup whilst in Germany and conquering all of Europe? I don't think I'm charismatic enough for that, to be honest. But I have to believe, I want to believe that if I did do that, it would be for the right cause. Probably just like, let's get some climate action going, please. So let me just copy this over to each one of those. Constraints, copy to selected objects. Boom. Okay, so now we've got our neutron with the quarks inside, and wherever I put the camera, they will face the camera. So if I put the camera here, now they're facing the camera. Ain't that cool? I don't know, I love that stuff. And I would just do the same thing over here. Where in Germany are you? I'm in Jena, so East Germany. You've drunk? I was never a big drinker actually. So when I started drinking when I was 18, and I sort of overdid it for a bit, and then I kind of just stopped drinking, and so I never really acquired the love for the taste of beer, and so I just don't really drink. But I mean, I've been told it's very good, but it's not for me, unfortunately, for the beer lovers. I'm sorry to say. Oh, cool. God, what am I doing here? So this guy is the collision, actually. And then we need another guy on the inside to be particles. Can you lock U and D to always face the camera? Yeah, so they are always facing the camera. So that's, so over here on the right side, this is where all your tools are. And this is this little thing that looks like a, I don't know, like a close clip? I don't know. It's called a constraint. And so you can constrain them to do various things. So one thing I've done is I've constrained them that no matter where they are, they must rotate to look at the camera. And I forget the hotkey to lock camera to view. Here we go, camera to view. So now wherever I move the camera, you'll see that they're always facing the camera. See? Very, very convenient. So, like I said, again, anything is possible in Blender. You just have to have a little imagination. So this will be the collision. 28. A hand sculpted specimen. My knees beg to differ. I think I might have to start. So right now I'm big into bouldering, but I'm starting to think that's not the best thing for my knees. So I might have to just do boring old gym instead of bouldering, because bouldering is really fun. So. And then viewport display, don't show me that guy. How big are they over here? They are 0.28. My name is Jaren. So, I'll be honest, it's probably not that hard to find me. Yeah, so I am working on the gym buddy aspect right now. So I'm not worried. Like when I went to Puerto Rico, being an introvert in a non-English speaking area was pretty difficult. So I basically lived at the gym. So I'm fairly decent with gyms, but I just have been preferring bouldering at the moment. So proton quarks, we need you guys to reflect each other. And we need to turn off gravity. There we go. And then we just have to do this thing with a new set of levers. So we'll duplicate the collection. And then yeah, Jaren from State Farm at 3 in the morning. No, I'm well asleep by 3 in the morning. I take my sleep very seriously. So I'll take this dude. And this guy's proton quarks. And then we need to change one of these to an up. And there we go. I appreciate the what's the word? The confidence, Jason, but maybe hold off till you know what I look like before just spouting this crazy stuff. Isn't it tiring making the animation? So some things are more fun than others. So I mean, normally this kind of stuff right here, like I love this shit. I love doing this and figuring out how to do it. But then like the hand kind of animations, those are not particularly fun. And also, like, it doesn't take this long. I'm very distracted. I can't really focus on the processes that takes to do what we're doing right now. But yeah, there's some things. So there's most videos. Usually, the thing that gets left to last is the thing that requires the most hand animation, and I'll just be like, eventually, I'll force myself to do that. Yeah, I don't know why that keeps happening. So why are you over here, Mr. Dude? You should be over here. Proton quarks, get the locations. Cyclic, target 2. That's really weird. I don't know why that's happening. Yeah, I don't think I have my internet's designed for continual upload or whatever. If I was a professional streamer, maybe I would talk to my ISP about sorting things out like that, but it's not the worst thing in the world. I will let you guys know. I think I'll get off in 24 minutes at 9 my time, Central European. Try to solve this problem here. Why this dude is not here? Oh, it's got to be something to do with why are you doing this to me? Just show us a real quark. Zoom in 5 times on iPhone camera. Yeah. I don't want to deal with this right now. I don't know why this isn't where it's supposed to be. You're supposed to be there. Why aren't you there? Oh, what the heck? I am so confused why that worked. Okay, I'm not gonna touch it. If it works, it works. Alright, last thing to do here is just make my strong force things. I already have that. Uh, There we go. So we got a strong force there, and a strong force here. So, good enough for this scene, I suppose. We got our quartz. Let me go look at the script. What else do I need? Yeah, I'm in Europe right now. So originally from the US, went to bachelor's in Puerto Rico. Now I'm in Germany. And the reason is because the US's education system doesn't really want you to succeed without crippling debt. And I don't know a lot of scientists who can survive $100,000 worth of debt. Because the university I got into in the US was $34,000 a year, which was ridiculous. Oh, I can work on that guy. I know what I can do now. All right, let's do that scene. Okay, gotta share this new window. Alright, so this is my take on a proto-neutron star. So you can see we got a little bit of jiggly going on. Oh my god, so my internet is super reliable on the download, but I guess the upload is kind of sketch. So what's going on here is at the very... This is what I needed the help with to make sure I'm describing this process correctly. Is the process, it's called the Urca process, the direct Urca process. And basically what happens is that you have, neutrons, there's a couple of protons in there, I don't have them, and you have electrons. And what happens is that these neutrons have so much energy that they decay into an electron, a proton, and an antineutrino. But then, because there's so much pressure, the electron goes right back into a proton and forms a neutron. And then the neutron goes right back, and it goes back and forth really fast. So actually what I'm going to show here is actually the mechanism that holds a neutron star in place. So what we need to do first is we need to create a neutron material, because I need to look inside of it to show this neutron guy here, my free neutron. Why can't I move you? Are you locked in by animation nodes? Okay, weird. So anyways, I need to be able to show where this dude is supposed to go. Inside. So what we're going to do is we're going to create a neutron material, and we're going to look and peer inside by messing with the alpha. So we're going to create a gradient texture. Get a sphere. So this is where the nitty-gritty of Blender comes in, trying to make materials do what you want to do. This took ages to learn, so if you're like, holy shit, yeah, you don't just start out doing this kind of stuff. It takes ages to figure out how to do this. So what I'm doing here is I'm going to affect the alpha. So the alpha is like how you can see through. Is the little ball thing not a? Oh, it's not applying. Okay, where's this dude? Is it this dude? This guy needs to have the neutron material. There we go. I guess the neutron material also needs to have a bit of emission to it. So this is the alpha affects how well you can see through it. So what I'm going to do is I'm going to hook up a object to pass through it, and then it'll reveal what's around that object, which is what I'm doing right now. So plug this into alpha. And then, so now it's backwards. So now when this comes in, it should, yeah, so now it's revealing it, so we want the inverse of that. So. So now when this guy comes in, he will, let's make it bigger so you can peer inside what's going on here. Isn't that nifty? And I don't like the fuzziness, so I'll just make this a constant. There we go. So now this guy also needs to be its own neutron. I swear to God, thinking about the universe and time keeps me awake at night more than it should. Don't do that, dude. Just as long as you find your place in the universe and time, that's what you gotta do. But I understand. I'm not gonna pretend like I magically found Zen. Yeah, I don't see any questions at the moment. All right, so this is the dude I want to see break apart. So I also think I don't need to see these electrons, so we have to do the same thing with the electrons. And I want the electrons to be slightly visible, because that's the point of what I'm going to demonstrate here, is that these electrons are still around. So there you go. See, isn't that cool? Take a look inside. So basically what happens in a normal neutron star is that neutrons are not stable. They like to decay into protons and electrons and antineutrinos. However, in order to do that, they need to put their their decayed results into the environment. And in neutron stars, there are electrons knocking about, and those electrons are what are called degenerate, which means they're really, really squeezed up together, and they're in really high energy states. So in order for this neutron to decay, it needs to have the energy to force an electron into the electron degenerate area. And since it requires a ton of energy to do that, the neutron simply can't decay, and that's what keeps a neutron star in check. And if there's not a lot of electrons, then a couple of neutrons will decay, and then the concentration of electrons will build up, and then the neutrons can no longer decay. So it's sort of a stable system. That's why it doesn't go anywhere. So now we just need to have this dude. Can you show an electron converting an up quark to a down quark? I sort of did that in my last video. It's just the electron comes close up to the proton and goes rrrt. So watch the stellar corpse video. No, it's the last video I did. It mentions that. So we'll just say neutron here, and then it decays. And then it produces a proton. I mean, I mean, I totally get existentialism, but there's also just sort of a thing in just not caring and just being like, I would love to know what's going on, but I don't see that happening. I'm getting a little tired, so I'm a little bit less talkative now. Hence, you might notice a little pickup in my ability to do stuff. So now we have our neutron, and he goes yoink. And then we have to make an anti-neutrino that flies off. Someone wanna fill in Jared for me? I've answered that question like 4 times now. Can someone explain what my next video is? But it's going to be, in essence, it's about core collapse. So it's about how large cores of large stars collapse, producing a supernova and crazy events that happen. So anyway, let's create a... So this will be my... my neutrino. There you go. That looks like a neutrino. We'll make him a very bright purple. And should we turn on some bloom so we can find it? There it is. There's my little neutrino. So we have decay into these guys. Yeah, so unfortunately, until I can get my script going and actually know how I'm going to animate a lot of things, it's not super sexy animating things. And a lot of the stuff that makes it looks good is what you do at the very end. I don't have any experience with Cinema 4D. The reason I picked up Blender was simply because it was free and I didn't want to go through the hassle of acquiring Cinema 4D if it was super, you know, expensive. And not expensive, but complex. So just like, why go through that hassle if I don't even know if I'm going to stick with it? So since Blender was free and super, what's the word? Super low profile, like it's only 200 megabytes. It's insane. I just picked it up, and you can, as far as I understand it, when it comes to just like raw visual stuff, Blender can go toe to toe with everything else. But you would want to use Cinema 4D, and can't think of the other ones, but the other main ones for like simulation, mainly simulation, and just various things like that. But I have to imagine, I haven't seen anything produced visually in Cinema 4D that doesn't look like you can make it in Blender. But as far as like physics and just like animation, yeah, there's some stuff that I don't think you can do in Blender. Yeah, I'm getting kind of like I don't really know what else to do without a script telling me what to do next. But yeah, here's my little neutron going, and then this guy will eventually. Let me hide this. Can I hide my electrons? Don't need you anymore. This guy will just zoom out. That was way too quick. There he goes. Yoink. Maya, yeah, Maya's the other one. But Maya, you have to deal with the dirty business practices of subscription-based software. No one really likes that. I don't see. So this is a question to Arthur asking if YouTube is a career for you. I don't like the idea of YouTube as a career. There's just too much uncertainty. But education, visual education, is something I have always planned to do after I get my PhD. The question is, do I finish my PhD before I move on to that, or do I get like some sort of offer of stability before that? I mean, right, my PhD is very important, and so I feel compelled to do it, even if it's not the thing I want to do the most. I mean, I still really want to do it. It's just, like I said, I enjoy doing this stuff and researching these topics a little bit more than my PhD. So, yeah, God, I feel like I'm boring because I don't know what to do now that I've done this little scene. But yeah, so I definitely can see myself doing something education related similar to this. Let me look at my script here. But right now, this is just a passion project I do, and hopefully I can complete my PhD in record time. My PhD is going to be machine learning to... Hang on, let me read my script really quick and then I can... Ooh, I can work on that. That'll be cool. I want to see if I can do that with animation nodes. So I can just do it. So my PhD is going to be with machine learning in... PhD in machine learning to predict high resolution reactions to specific... Oh, my words are failing me. Does someone remember what I said earlier? Climate extreme events are going... We can model climate extreme events right now. We can see what they're going to do on a very coarse scale, so like over entire 1 degree grids over the Earth, but we don't know what that means on a small scale. So what we're actually going to try to do is, I'm going to predict what that looks like on a small scale. So if you're like a farmer or whatever, and they say, hey, this other machine learning model has predicted an extreme event next month for you, then my machine model will say, this is what it's specifically going to look like for you. So that's the dream, that's the goal. But I cannot guarantee it'll work, but I have the game plan, or the what I have to do to figure that out is pretty straightforward. So I don't know if it'll take me the full amount of time. I hope not, but it might. But yeah, so it's climate related. I mean, I have a huge passion for working for climate stuff, so I feel compelled to actually do my PhD and help out. At the same time, like I said, this is so much fun. Like, what am I about to do? I love doing simulation, which is what I'm about to do here. Let me hide this thing so you don't see it. But I'm about to do some simulation stuff, which is awesome, especially when you do simulation stuff with molecular. The molecular add-on. Oops. So what I'm going to do is put a force field at the middle here. Crank this guy way up, and then I'm gonna try to see if I can create a this is gonna look really cool. I'm gonna see if I can create a 5,000. Hell yeah. See if I can make some sort of 5,000 might be too much. See if I can make some sort of shockwave that happens when the objects collide with the core. My master's degree was in Earth and Climate Science, and my thesis was using satellite images and machine learning to predict what crops were growing in specific fields. So now we do molecular, self-collision, and we're gonna bump this way up to like 10,000. All right, let's see if we get a shockwave out of this. Oh, I forgot to turn off gravity. Shit. There you go, that looks like a shockwave. Perfect. That seems possible. I think we can bump it way up, actually. Let's do 50,000? Why not? Let's make it, oops, not this guy. Get a little bit bigger. So I get it's a joke comment, but I'm doing this because what happens when the core collapses of a massive star is that all of the matter bounces into it and it starts a shockwave back. Now, believe it or not, that is not the principal cause of a supernova. Because if the star is really, really big, this shockwave, well, first let me just, oh wait, no, I don't want to do it that way. I want to do it with molecular. What am I doing? So molecular does a much more accurate simulation. So actually we'll add up the sub-steps. Woofda. So yeah, that's crunching a lot of numbers. But basically, the material will slam against the core of the massive star, which is insanely dense. Like it's basically slamming against an infinite density. It's not infinite density, but just imagine the hardest surface possible, and it's going to bounce out and it's going to send a shockwave rippling out. But if the star is too big, so if basically if the core is, or if the sun, if the star is above about 20 solar masses, it will have a lot of iron around the core, and that shockwave will go through the iron that isn't turned into the core, and that iron will disintegrate, absorbing a ton of the energy from that shockwave. And so for very, very large stars, this collapse of the core and the shockwave isn't enough to actually produce a supernova. So the question is, how do really large stars produce supernovas and not always produce black holes? Because not every large star will produce a black hole. So I don't know if this is going to be interesting. Yeah, you can sort of see, I mean, that's pretty cool, eh? I think that's cool. That kind of shows it right there. You can see how that works. So that's good enough there, see? So that's kind of how it works in a very, very simplified manner. But basically, the shockwave will, for very large stars, it gets absorbed very efficiently by the iron. The iron breaks apart, and it cannot propagate out to cause, you know. So imagine it would like kind of like come out and then kind of all come back in. You wouldn't have all this crazy stuff out here. And it would just form a black hole immediately. Every single large star would. So the question is, well, not every large star forms a black hole. So how do you get a supernova? And that's what I was doing earlier in, was it this scene? Yeah, in this scene here. So when these guys decay, they produce an unimaginable amount of neutrinos. And those neutrinos will fly out and they'll work with the shock wave to cause the expansion and whatever of the supernova. And that's where you get the energy to fuel this crazy thing. Well, yeah, it's 9 o'clock. I went 30 minutes, a little bit longer than I wanted to. So I appreciate you guys coming by. I think I'll probably do this again in like 2 weeks or so. I enjoyed it. Hopefully I can figure out why my internet keeps dropping. Anyways, thanks for stopping by. I enjoyed, saying what's up. And neutrinos interact with the Higgs field. Not that I know of. Hang on. I actually do my research at the Max Planck Institute here in Jena. So Max Planck is all right. I can't recommend it. I'm not like a scholar who can recommend things. But anyways, good night. See you, dudes.